Hello, my name is Jim LeGrant, and I am a professor of practice in manufacturing in the Mechanical and Industrial Engineering Department at the University of Massachusetts in Amherst. And this week, our spring semester classes have ended, and it's been just over a week since we had our spring design competition for our senior capstone design classes. So today, I'm going to share with you the results of our judging scores and introduce to you the winners of this semester's competition. We're going to start out with our semester-long industrial engineering projects. And in third place, we have team 7804 with Raytheon model-based engineering. This team's goal was to identify a software solution that would integrate within Raytheon's pre-existing model-based engineering system that allows them to exchange quality information with their suppliers in real time, enter their measurements into a single database, and then allowed cloud access to this data by Raytheon employees while maintaining security standards. This team analyzed Raytheon's current model-based engineering process and identified bottlenecks that could be eliminated and mitigated. And this included ballooning engineering drawings for both supplier purchased parts and internal manufacturing processes to reduce the time and errors associated with first article inspection and to streamline communication between Raytheon and their suppliers. The result of this team's recommendations has a projected first-year savings of just over $500,000. And our second place slot for our industrial engineering teams is Team 7803, who analyzed Webb Industries' production process. So Webb Industries manufactures and assembles at-home COVID-19 test kits. And this team's goal was to reduce the work in progress inventory by 50% while also reducing inventory staffing costs. And their final goal was to eliminate downtime and stalls within the conveyor system. So this team used Arena simulation software to replicate and manipulate the current conveyor system without affecting actual production. Arena provided queue sizes, duration, system backups, efficiency scores, conveyor speeds, and production rates to assist in creating appropriate box queues to minimize downtime and inventory holding. This team's redesign removed 50% of excess work in progress inventory and 70% of inventory-related labor costs, which equates to approximately a savings of $312,000 annually. And by simply relocating a conveyor sensor, the team allowed for a 30% increase in production, exceeding their previous production goal. And in first place, we have the Human Performance Lab Novice Driver Training Team. And this team used human factors principles, heuristic evaluations, and usability surveys to improve a web-based novice driver training program. Their initial assessment of the usability of the prototype team driving program was meant to improve higher order driving skills. The team refined the prototype following user-centered design principles and sponsor specifications, and they then assessed the usability of the final prototype of their program. And the team did this by using the Computer System Usability Questionnaire and the NASA Task Load Index to support this. These evaluations focused on human factor principles such as aesthetics, elimination of errors, ease of use, and user success. And they ensured compatibility between the users and these computer systems, specifically pertaining to the system's clarity on information, pace, functions, and capabilities. So congratulations, Shah, Ryan, Sarah, and Nick. Moving on, we're going to look at the semester-long mechanical engineering projects. And in third place, we have our bedpan redesign team. This team collaborated with the College of Nursing with the objectives of redistributing patient skin pressure by increasing the surface area of the bedpan, by reducing the strain of rolling the patient on and off the bedpan by the nursing staff, and to increase the bedpan volume to minimize spillage. This was a especially interesting project because the team really had two customers. They had the nurses who were using the bedpans and the hospitals who had to purchase these bedpans, as well as an end user being the patient themselves. And their team's prototype has a unique rounded UFO shape with a larger sitting area, which allows the nurses to roll the patient on and off with greater ease and redistribute the pressure on the patient's body, lowering the risk of pressure injury. In second place, we have our Boris stroller attachment, which was a concept by a student in the Eisenberg School of Management who reached out to our department with help to come up with this design. And their goal was to create an instrument that provides a fully adjustable and safe hands-free option for parents and caregivers to eliminate the discomfort when pushing a jogging stroller. Their prototype achieved their four main objectives, which would allow the user to steer the stroller hand-free, to detach when the user falls, attach universally to any stroller type, and be adjustable for user comfort. And in first place, Team 1509 designed and fabricated a clamshell emptying device. So over 50% of the mass of recycling and trash at Blue Wall is food waste trapped in clamshells. For every metric ton of compost that can be diverted from a landfill, the production of approximately 0.71 metric tons of CO2 is successfully avoided. So this team was tasked with developing an automated device capable of emptying plastic to-go containers and separating the plastic and food waste. So they developed a working system where their users dispose of their clamshells into the device's hopper. The clamshell is then transported away from the hopper via a rotating arm where suction cups open the clamshell and dispose of the compost into a collection bin. And then the subsequently empty clamshell is ejected into a separate recyclable container bin. So congratulations, William, Peter, Alden, Dhyan, and Alexander. And finally, our third category is our year-long mechanical engineering projects. In third place, we have the augmented reality pilot process application. So this team developed an application based around the student-built smart pilot process that can operate virtually and in presence of the machine. The AR has two goals. The AR application has two goals. The first of which is to teach operators or other non-technical users how to operate the machine, as well as how the machine works, how the process works at a basic level. And their second goal was to teach engineers, whether they were junior engineering students or engineers responsible for the process, to diagnose and fix issues with the machine and to communicate the relevant engineering standards, parts, and specifications. In second place, our team developed a tension monitoring and braking system for Quabbin wire and cable. Currently, the tension is measured by a handheld device by the operators at some period throughout the day. This device is very subjective to how the operator holds it. So they were tasked with designing a tension monitoring system that was low cost, accurate, repeatable, and easy to use. Their concept uses sound and displacement of the wire, allowing the tension monitoring to be monitored automatically without the need for an operator. And the sensors provide the frequency of the oscillating wire, which then can be translated to the tension of the wire within given parameters. And then finally, in first place, a team which should be recognizable from the end of the first semester is Team 9708 for robotic wick optimization. This team was tasked with improving the per piece minute output for 3 wick candle production. They accomplished this by creating 4 separate devices to enable automatic positioning and tensioning of these multiple candle wicks prior to the wax pouring process. By implementing these devices in parallel with a collaborative robot, the candle throughput rate increases as the robots can operate at speeds much faster than human operators. Additionally, the quality of the product improves and the tensioning of the wicks become much more consistent due to the high degree of repeatability of these cobots. So congratulations, Team 9708, Patrick, Jennifer, Sidney, Kathryn, and Enzo. And to all of our teams, great job. And we wish you all much success in your future endeavors. And for those judges that are watching, we hope to see you in December for our next round of teams. Have a great summer, everybody.